Hey, how we doing today? Coach Jay in the house. Hope you're having a fantastic evening as we finish off the last test of the semester. Can you believe it? Just encouraging you. Hope you really put some good time and effort in as we wrap this up. Remember, a couple study sessions coming up. Make sure you tune in to my help sessions there in the morning, and we'll go from there. Hey, let's get this thing underway with my jazz music there. If you hear my daughter screaming, that's because she is. And we'll do the best we can on that, all right? So let's get this show on the road. I'm going to turn this down just a little bit. There you go. And we're going to get straight into the hard ones. How about that? We're going to go straight into it. Now, some of the ones that we're going to look at today, you have not, some of you have not gotten this as far as the review is concerned. So as we go through it, if you have questions, please feel free to text me. You could do it through Remind 101, or you could do it through just my direct phone number, and I will give you those questions as soon as possible. All right, so let's get this show on the road. All right, so one thing that we've got to remember in any of these problems that we're looking at is one like number 14. We'll kind of start from 14 and we'll work our way down here. But it says that the wind is blowing at 20 miles per hour in the direction of north 30 degrees west. Now, the big thing to kind of represent this is, remember that vectors have two things. They have what's called magnitude. A lot of times that could be represented as like distance or velocity a lot of times. And the second thing it has is a direction. So both of these things kind of play on each other. So for instance, if I go north 30 degrees west, I'll start at the north side and I'll go 30 degrees to the west side. So it should look like this. So 30 degrees is going to be going this way. Okay. And so we'll have north 30 degrees to the west. Okay. Now, once I get to this point, I also note that we have 20 miles per hour. Remember, our magnitude always follows our hypotenuse. So if I was to create a triangle, some of you may create this a little bit differently, and not that it's wrong, but I like to always create it with the x-axis. It just makes it easier for my eye. You could make it up top, and that would be okay. It just would be a little bit different. But on this hypotenuse, that 20 miles per hour is actually going to go on top of it. So it should look like this. So 20 would go right straight over top. So now what we have is we have to express this velocity in terms of a vector. And we want it in terms of I and j. That's a vector, right? So we have v equals ai plus bj, where a and b are two whole numbers there. And so a would be like this area. This is like the I, right? So the I is going to be here, okay, left and right, and the j is going to be up and down. So that b is going to be kind of up and down there, okay? So the goal of this is to figure out what is a and b, right? What is a and b? So I can do that by doing some SOHCAHTOA stuff, okay? So if I were to do this, I could just say sine of my angle. Now the angle that I'm using, I've got to use kind of this angle down here. This one right in that area. So if this is 30, 90 minus 30, this angle would then be 60 degrees there. So I'm going to say sine of 60 equals my opposite, which is b, over my hypotenuse, which is 20. So I'm going to multiply by 20 on either side, okay? And remember, make sure that your calculator's in degrees. That's a big deal. Make sure your calculator's in degrees here. And so you'll do 20 sine of 60. Sorry about my daughter. She here there. She's cried there. So my b is equal to 17.32. And we'll put it to the nearest hundredth. That'll be good. The next thing we've got to do is find what a is. And so to find a, we're going to use cosine. So we'll do cosine of 60 again equals a, which is my adjacent over my hypotenuse, which is 20. So I'm going to multiply by 20 on either side to get 20 cosine of 60. In that case, it'll be 10. So my a is equal to 10. So one thing to remember though is what type of signs, when I say signs, what type of signs, like is it positive or negative? Okay, that's important. So like if I go to the left hand side, this is going to be a negative A. Because I go up, that's going to be positive B. So what I'm going to say is negative 10 I plus 17.32 J. And that's going to be what vector V is equal to. Okay. So, and then that's what I'll leave it just like that as right there. Because again, A would be this adjacent side. Remember, cosine's adjacent over hypotenuse. So it's using the x-axis. Whereas for sine is going to be the opposite side. And that's why we have the B there. Okay. So it'd be north 30 degrees west. That's where I put it here. Okay. And then I use that to go forward to find what vector V was. All right. Now this next one is the pulley system. We have two different pulleys pulling in two different ways, but we're pulling from the same thing. So if you think about it, this pulley system is trying to pull this thing from the bottom. Okay. So it's starting from the bottom and it'll be there. Start from the bottom and the whole team will be there. Okay. So just giving you a heads up. All right. So, and then you juju on that beat. Okay. We'll do that right after. Okay. So now we've got north 36 degrees east. So we're going to start from the north and go 36 degrees to the east side. Okay. So we're going to go 36 degrees right there. Okay. So then what we could do is take 90 minus 36 to put the angle right here. Again, same thing, right? So we have our A and B. Both are going to be positive, right? Might make a note of that. That might be helpful for you as you go forward. But 90 minus 36 will end up being 54. So we're going to put 54 degrees there. Now, as far as the magnitude, this time it's no longer velocity. This time it's like force, right? So we'll put 200 pounds right on the hypotenuse there, okay? So that's what we've got. Again, we've got that for this first force moving forward. Now, the second one pulls north 10 degrees west. So we go 10 degrees on the west side, okay? So it's this 10 degrees should go about right in there, but we don't want that one, right? We want to go down. Same thing. So we have A and B. B is positive since it goes up and down, where A is negative. Now, because of this, we have two different forces that are pulling on this one object, right? That are pulling on this object that's starting from the bottom, okay? And it's trying to pull its way up. So we want to try to find both vectors in terms of I and J. So if this is 10 subtracted from 90 will be 80 degrees, and that's how we get that there. Now, we then move forward through this, and as we progress forward, we have two vectors. We'll have force 2 and force 1. We'll do force 2 on this side. We'll start off by saying sine of 80, okay, this angle 80 equals opposite. Remember, the opposite is B right here over the hypotenuse. Now, the hypotenuse I forgot to put on this side. This is actually 150. It's my fault. So it's opposite over 150. Remember that cosine's the same thing. The only difference now is that we do adjacent, which is the A over hypotenuse, okay? Now over here, you'll start noticing it's pretty much the same thing, right? So you can multiply by 150 on both sides, right? And you could go from there, right? So you get A by itself and all that. But you start recognizing a pattern with these. And if you can recognize it, great. On this one, it should end up being 200 sine of the angle of 54. And that will be my B, because that's the opposite. And my 200 cosine of 54 will equal my A. Okay, so let's plug those in. This takes a little bit, but we'll be good. So 150 sine of 80, it's 147.72. This will be my J. And 150 cosine of 80 is 26.05, 26.05. And that will be my I. Okay, and remember, this one's negative because it goes to the left-hand side, whereas this one's positive. That's important, okay? So we're going to put that together. Usually you'd have it as 1, but since we, just for sake of room, we'll keep it as V equals the I and then the J there. All right, so let's do the sine. 200 sine of 54. Got 161.80. This is going to be my j because it's opposite with sign. 200 cosine of 54. It's 117.56. And that's going to be my I. All right, so we've got these both are positive since it's in the first quadrant. All right, perfect. So now, since I've got kind of both of these here, we're going to combine these together. So like we then, because we have two that are being pulled, we get each of them individual, kind of like what we did on 14, except now we've got to combine these two together to get my resultant vector. Okay, so we'll just say that this is, and you could actually put it as R V, that's fine. And so you would say, and we'll do the I's first. So 117.56 minus 26.05. So I'm sorry, I messed up on that. You kind of follow me through with these. Get 91.51. So we'll do 95.51 I, and let's do the J, 147.72 plus 161.80. Perfect. So we have 309.52. So my resultant vector is this right here. Now let's look and see what it has. It says with both forces pulling together, how much force can be pulled together? So really, we have our individual forces, right? But you've always heard, like, if two oxen, oxys. How do you say oxen plural? Is it oxys? Go fetch my oxys, or ixies? I don't know. Whatever. Ixies. Go fetch both my ixies, oxys, and see how much they can pull together, right? Well, it's the same thing true here. There's one thing with two forces. This is my resultant force when I add both force 1 plus force 2 together. I get my resultant force, right? So what I've got to do now is I've got to find what the magnitude is. And I can do that by doing a squared plus b squared equals c squared. Or if you want to, kind of in your calculator, you could put the square root of 91.51 squared. Make sure you put this in parentheses, by the way. So all should be in parentheses. Plus 309.52 squared. Put that in parentheses and then square root it. And so then you could get your force. Now, it should be greater than each of these numbers, okay? So if it's not, you did something wrong. So be careful. Or if this was like a negative in here, make sure the negative's included on that, because sometimes it can be thrown off. So I'm going to do the square root of, and I'm just going to plug this one in, 91.51 squared, and then plus 309.52 squared as well. Okay. All right. So let's take the square root of that to get 322.76. Nice. So 322.76. And that is my vector. Remember, two lines around it means magnitude. That's the amount of force in terms of poundage that two oxys or oxen or oxys can pull there. Okay, so that's the resultant, how much force can be pulled together. Okay. All right, I'm hoping this is making sense. If it's not, let me know, and we can come back to those questions. But I'm hoping that this is moving through very nicely here. All right, let's do the next one, and I'm going to erase this. While hopefully you can always go back in the video. That's the beauty of this here. If you have any friends or family members or people from Sweden, I have a lot of people from Sweden who watch these podcasts, but if they need some help on any of these, please let them know. Share this with them, and we'll go from there. Okay, so let me give a disclaimer on 16. The only difference between 16 and the actual test is I know that the angle that we normally would put here would be a bearing. So we would say like south 30 degrees east or something like that, okay? So if I did south 30 degrees east, just a heads up, I'd go south, right? 30 degrees on the east side. So this would be 30 degrees, right? I would have to make this triangle. 90 minus 30 is 60. 60 would be there, and then that's how you would do it. But because this one's a little bit different, we're just going to go off of this, okay? I'm just going to kind of go off of it. And what we're going to say is this, and this is kind of similar. We have our plane, okay? and we have our wind. And our plane plus our wind equals what we call our ground speed. Okay, you'll see that here in a second as we go forward. So, for instance, it says a plane is flying at an airspeed of 400 miles per hour at a heading of 204 degrees. So, and I know that some of you have learned different things. Just for sake of argument, for this problem, I think on the actual answer sheet, it could be a little bit different. But I'm going to go off of what the test is going to be over, and I just don't want to confuse you, okay? So we're going to say that 204 degrees starts at this spot and goes all around past 180 to now 204, okay? So that's 204 degrees. All right, so since that's 204, it then says it goes 400 miles per hour. So we're going to put 400 on the hypotenuse. Now, as far as the wind goes, it says that wind of 45 miles per hour is blowing from the east. So if it's blowing from the east, right, if it's blowing from the east side, then we are literally going this way, okay? So we're going to the left, everything mounts in the house to the left, in the closet, there's something like that. Isn't that right? I hope so. All right, so, and it travels at 45 miles per hour, so 45 is the magnitude, all right? 45 is magnitude. Now, one thing to remember is we know we have to solve for what I and J is, okay? Or in this case, A and B. We know since it goes left, A is negative, and since it goes down, B is negative. And that's important to kind of check, because if you mess up on that, it can be tough to really get this problem correct. So just a heads up there. Now, one thing we want to remember is that we want to find the angle that's connected to my Y here, or to my X, I'm sorry, my X-axis. So I can take 204 minus 180, because we know this is 180 right here, that semicircle. So 204 minus 180 equals 24 degrees. So we're going to put 24 degrees right there on that interior. So what we're going to say is sine of 24 equals opposite, which is B, over hypotenuse, which is 400. Okay? Now for our cosine, we're going to do the same thing, except now we'll say cosine of 24 equals adjacent, which is A, over hypotenuse, which is 400. So what I'm going to do is I'm going to multiply by 400 on either side. Okay? And what we'll end up getting is 400 sine of 24 and 400 cosine of 24. Okay? Awesome. And yes, so that's kind of where we're at. Okay? And shout out to Ashley real quick. She wants me to do number 13. Ashley, thanks for showing up. Appreciate you for doing that. And yes, I will get to number 13 here in a second, once I'm done with this last word problem here. So just like we did on the previous one with the two force problems, let's plug this in our calculator, or calculador, as they say in Sweden. So 400 sine of 24. Let's see. Oh, good question. Someone just asked how they were confused. So how did we get 24 degrees in here? Well, remember that, and this is just kind of a side note, 204 is a little bit greater than 180, right? So we know it's in quadrant 3. That's why A is negative and B is negative, right? Because it goes left and down. And we know that 180 degrees is like the semicircle angle, right? And so since 180 is up here, if the whole thing's 204, I could take 204 and subtract 180. And when I do that, I should get 24, and that's how I got 24 degrees. Okay? So hopefully that made sense there. If it didn't, let me know, and I can go through that again, and we can hit that going forward. Okay? But when I plug this in, my first vector is equal to negative, by the way, because both are negative there. 365.42 I minus 162.69 J. Okay? All right, so this right here is the vector for the plane. Now for the wind, this one's a lot easier, because since it goes just directly to the west side, we know that there is no change in J. It's not going up and down, right? Now, if it was going up yonder right here, then you would obviously need to do the same thing. But because it goes directly to the west side, because it says it's coming from the east, so we could just say that this vector, You could make it whatever you want. I'll make it vector u. It's fine. That is equal to negative 45i. The reason why is because it has no j. It's not going up and down. It's just going left and right. This is just a side note. If I had one that I said wind was going north at 20 miles per hour, what I would say then is this one would be u equals 20j, positive because it's going up. Okay, but we're not using that, but I just want to make sure I give you another one there. So now in order to get my ground speed, I need to add these two together, first vector as well as our second. And so when I add that together, the i's will be combined. Okay, so we're going to combine the i's together to get 410.42, negative 410.42 I. And then the j stays the same because there is no nothing we need to subtract. Okay, and so this is our resultant vector when I add these two together. Okay, now let's look and see what it says. It says this: find the ground speed and direction angle of the plane. So this is a little bit more in depth. That's why we're doing this one. Remember, we can find what the magnitude of the vector is by doing the square root of, and this is where you got to put in parentheses, negative 410.42, because if you don't, you're going to get a negative. You're going to get an error on this one. So just be careful. Be careful on that. Plus negative 162.69. You could also note, since you square this, you could actually make these positive, because you know that if you square it, it will end up turning into something positive there. Okay. The reason why I added these two together is because remember that with the plane is going at one speed, right? But remember, it may think it's going this way, right? Let's say if the plane, let's do the actual problem. So the plane thinks it's going this way, but because wind is impacting it here, really this plane is going to end up being headed more towards this way. So basically the wind affects the actual, even though the plane thinks it's going in this direction, the wind, because of the 45-mile-per-hour wind, it's affecting what it's actually doing, and that's what we call ground speed. All right. Now, what the plane thinks it's doing, it may think it's going straight to San Francisco, but that may not be the case. Maybe because of the wind, it may veer off course and push it more towards Los Angeles or something, and that's why that's so important to take this into account. So this right here is the what we call the ground speed. When we add the plane plus the wind together, we get what the plane is actually doing. We call that ground speed. All right, so if you were on the ground looking up, you see the ground speed. You see the wind affecting what the plane thinks it's doing. If you're still struggling on that, I can look at that in class as well, okay? I'm hoping that will help y'all on that, because I know that that can be a little tricky. All right, so I'm just going to plug this in my calculador here. All right, so I need to have some music. Don't you love the jazz music? Those that are in my class, this is just lovely. All right, so the magnitude of this is 441.46. And that right there would be the, I do love that song, by the way. Don't like Christmas, but I do like that song. This would be 441.46 miles per hour. Okay, because that's what we're talking about in terms of our magnitude. And so we'll leave that as is. Now, as far as the actual angle, this is where it gets a little bit tricky. To find where our angle is, remember this is both negative, right? So we're still in this quadrant. We know that the adjacent is 410.42, and this side is negative 162.69. So to find this angle, what we can do on that is we can actually say that this is theta, because we're trying to find the new angle of this new vector. And what you could say is tangent of theta equals opposite, which is negative 162.69, over adjacent, negative 410.42. And to get theta by itself, what you could do then is do tan inverse of on both sides. So tan inverse of negative 162.69 divided by negative 410.42. And once I get to that, I get 21.62 So theta is 21.62 degrees. Remember that with this, the reason why I had to do tan inverse is to get tangent out of there, right? Because I got to get theta by itself. But remember, with that 21.162, we're going to add 180 to it. The reason why is because you got, again, starting at 0, we'll add 180 to it. And once I add 180, I could get 201.62 degrees. So that's actually the real angle that it's headed at, starting from 0 and going around the direction angle there. You could also put it in a bearing. If you wanted to go, you could also say this. You could subtract 21.62 from 90 to get 0.38. If I subtracted that from 90, 68, correct me if I'm wrong, by 68.38, and you would say south, because you go south, 68.38 degrees, and then it'd be to the west side because it's going to the left. You could also put that as well. You could put either of these two, numbers 1 or number 2. Okay, I'm guessing that on that one we will probably go through that again at some point. But that one's a little tricky, and so I understand. That's a good one. All right, all right, now. Ooh, there's number 13. Let's look at number 13. Oh, yes, this one's very nice. Okay, so remember that with 13, we have our quadrant, here. 113 degrees is over yonder. Remember, it's just short of 180. It's between 90 and 180 to get to this quadrant. Just like we said beforehand, we have our A and we have our B. The B is positive because it's going up and down, and the A is negative, going left. I think I said that weird. B is positive because it goes up. A is negative because it's going to the left. All right, so we've got that. Now, the V with 2 lines means the magnitude, which is 1/2, will be plugged in for my hypotenuse. So 1/2 is going to be plugged in right on that hypotenuse there. And since the 113 is here, we're trying to find what this angle is. Okay, so we can do 180 minus 113 to get 67 as our angle that's there. So this angle right on that side would be 67 there. Okay, let me make sure I don't have any. Yeah, Maddie, that's a good point. That last problem, and let me come back to that one. This one right here, that one was a little bit tricky. Remember that the more that there is to this problem, the more opportunity there is to give a lot of credit back. So here's, instead of saying, oh, I hope I don't get one part wrong, think, okay, I know how to find the plane. I know how to find the wind. I know I need to add them together. I know how to find the magnitude. The actual direction angle might be something we need to look at. But the whole process, it's just, there's a lot of decimals, there's a lot of numbers being thrown out there. You forget, it's easy to forget a sign. So I get where you're coming from. All I could tell you is that, keep with it, because I think we can do this, all right? We can definitely do this. So keep at it. Okay, so 6 is that angle that's here, right? So if 67 is the highlighted angle, we're going to use that one. So we'll say 7 equals, remember it's opposite over hypotenuse, right? Well, the opposite side is B, and the hypotenuse side is 1/2. So what we're going to do is we're going to multiply by 1/2 on both sides. And 1/2 sine of 67 will get us what our B is. Now to get what our A is, we could just use cosine. So 1/2 cosine of 67 equals our A. But just remember that when we plug it in, whatever we get out will be negative, since it will be going to the left side. So as we back up, we're going to plug this in. So we're going to go 1/2 sine of 67, 0.46. I'll go 0.46, and this should be the J, right? Because it's going up and down. That's sine, that's the B, that's the opposite. And we'll do 0.5 or 1/2 cosine of 67. And for that one, it's 0.20, and that will be my I. So as I see this, as I plug it in, I'll just say my vector V by the way, this is negative, equals negative 0.20I plus 0.46j. And that right there is our vector, okay? If you were struggling on that one, maybe in class, we can go through number 12, or even as we talk about this, number 12 might be a good one to just kind of go over there as we move forward. If you have another question out there, we've got about 10 minutes left to kind of do one there. Let me know, and I'll go through it. I am looking through some of these, and so if you have a question, I'll be more than glad to do one for you. One thing I think we'll look at, if we looked at vectors pretty good today, I do want to get one of those on there, I think. Remember with these two, it's x2 minus x1, that goes with I, and y2 plus y2 minus y1, and that goes with j. Remember that the terminal always talks about the second, whereas the initial represents the first, okay? All right, so just remember that right there. All right, let's see who hollered back, who did a little holla back there. I think is that what y'all say nowadays? Number 10. Perfect. Let's do number 10. Okay, so yeah, this is perfect. This is actually what we just said. So x2 minus x1, right? Remember that the terminal is always number 2, and the x is, or the first one is, or 1 is always the initial. That's like my starting. So in this, like the x2 would be 4, and the x1 would be 4. So it should be 4 minus 4. That's my I. And my y would be 3, which is y2, minus negative 5. Okay, so make sure you plug that in still. So this would be positive with the j. 4 minus 4 is 0, so 0i plus 8j. And you could just say 8j is what my vector b is equal to. Okay, and that would be it. That's all you need on that one. Okay, that's all you need on that one. Okay, let's go to, I think we did that one pretty good. All right, these ones are one that I want to just kind of hit on. We will look at this a little bit more tomorrow. What we'll do is probably look at, probably a number of these. But let's look at number 4. Now, one thing I want to mention is just how to create a triangle. If I know that big A is 30 degrees and the little a is across from it, that's 10. My big B, I can put wherever I want to, but across from it's the 40, which is the little b. Then I have big C and little c. So as you look at this, you have as you look at it, you have an angle. You can't go this way, right? Because I skipped 2. I can't go angle this way. But I can go this way, angle, side, side. I can skip 1. So since I have an angle, side, side, I mean, don't write it like that. I apologize. I'm sorry. I would never do that. I would never say anything like that in class, ever. All right, so side-side angles here. We know immediately that we're going to go to our possible 2 triangles. Now, with our 2 possible triangles with a side-side angle, remember you'll have the chart. You'll have all of your formulas you'll need. So no stress on there. Just how can I apply it? So my first thing I want to look at is my first angle that was given. My first angle given was 30 degrees, so I'm going to plug that in for both. If I have 2 triangles, that 30 degrees is going to have to be consistent for both angle A's because it's given to me. So I'm going to say, in this case, sine of 30 over its opposite, which is 10, equals sine of, well, I can't do C because I don't know either. So I'll just do B. So sine of big B over 40. So let's cross multiply to get 10 sine of B equals 40 sine of 30. Divide by 10, divide by 10. And once I do that, remember, I'm going to have to take the sine inverse because it's sine of B on that left side. So I've got to try to figure out how to get that sine of B kind of not like unattached to that. So we're going to do the sine inverse on both sides. Okay. So I don't have to plug it all in. I don't actually plug it in myself. I actually do 40 sine of 30 and then I get 20, divide that by 10, get 2, and then I'm going to do the sine inverse of that. Now, once I do the sine inverse, I get air. Well, again, remember in an air, and this is the exception, within a side-side angle, or some of you who are very bad, say angle side-side, in each of these you can have 0, 2, or even no triangle. So if you get an air, you immediately go to no triangle. And that would be your answer. No questions asked, all right? Now, well, I don't know what happened there. Let's do another one here. Let's do number 5. Let's do number 5, yeah. So this, again, is a side-side angle. And I'll show you why here. Here's angle A, 60 degrees. Little a is across from it. Yeah, big B here, and little b is 18 across from it. Here's big C, little c. So I can't go this way, but I can say angle side-side or side-side angle, depending on how I go. And so I'll have sine of 60 over 16 equals the sine of big B over 18. Okay? Cross multiply. 18 sine of 60 equals 16 sine of B. Divide by 16, and we're going to take the inverse once we complete that. So again, like I said earlier, we'll do 18 sine of 60. Divide that by 16. Take the sine inverse of that to get 76.97. So I'm just going to say angle B is 77 degrees. Okay. So now as I, well, I don't know why I did that. Sorry. As I create my chart, right? Because of the fact that I could have 1 or 2 triangles, 1, 2, or 0 triangles, we're going to label this triangle 1 and possibly triangle 2. Now, since I have an angle for angle B for the first one, I'm going to plug 77 in for this one. And 60 is going to be plugged in for both. Remember, it's plugged in for both because it's given, right? Now, there's 3 places where in the chart that it adds up to be equal to 180. You have triangle 1, triangle 2, and the first angle I solved for, its counterpart. I don't care about C because that's not the first one. Only the first one I solved for. That and its counterpart have to add up to be equal to 180. So I'm going to take 180 minus 77, and I'm going to get 103 degrees, and I'm going to put that right in here. Now, as I go down for triangle 1, I'm going to take 60 plus 77, subtract it from 180 to get 43 degrees. So we're going to put 43 degrees in. I'll then take 60 plus 103, subtract it from 180 to get 17. Now, if this triangle did not have a third angle because they already exceeded 180, you would cancel triangle 2 out, leaving us just with 1 triangle. But in this case, since it worked, we can actually then keep this as is. We know there's 2 triangles. We're good there. And last but not least, we want to find what C is. But how many times do I need to solve for C? Well, I actually have to solve twice because there's 2 different angles. So we'll do it this way. We'll just say sine of 60 over 16 equals sine of, in this case, we'll do 43 first, over little c. And then the second one, we'll cross multiply, divide, right? And the second one, we'll do sine of 60 over 16 equals sine of 17 over little c. So let's plug in, let's see what we get here. So we're going to cross multiply. I got 5.40 for C here, okay? And then the next one. I got 12.60, okay? So in both of these instances, we're able to get 2 different side C's because we have 2 different triangles and 2 different angles for angle C, okay? Awesome, awesome, awesome. Okay, so hey, through a lot today. Good night. We got through the 3 main ones, 2 of these, and I think we did 2 other ones, 2 different style of ones. We really hit on most of them. The only one I didn't hit on was that one of those. I forgot to do the side. I'd like to do that in class tomorrow. This one's a side angle side. We can look at that one too. And then a couple of them in here. Well, these are more the basic ones. This is a side angle or angle side too. So just a heads up on that. Again, hopefully that was helpful for you. Again, let me know if I can help you out in any way. And man, I love the fact that there's 7 viewers tonight with a couple days to review. So, hey, you're in great shape. Maybe there's one tonight you just said, man, I still struggle on that. Well, you have a couple days. You have Wednesday morning. Tomorrow I can't do it, not tomorrow morning. But Wednesday morning, you have tomorrow in class that we're going to have a Q&A. So feel free, work through it, and own it. Whatever you need on that, let me know, and we'll rock and roll. Thank you so much for watching this podcast. I'm going to post this up on the top of On Campus. You can also watch this live on YouTube at any time on the following link. Anyway, have a great day. See y'all later. Bye. Bye. I'm sorry. Now we're bye. Bye.